Now moving to question number 67. Let's read the question. As you can see, the sum of the coefficients of all odd degree terms in the expansion. So it is not asking about all the degree, but only the odd degree terms. And what expansion they are talking about? X plus under root x cube minus 1 to the power 5 plus x minus under root x cube minus 1 to the power 5, where x is greater than 1. If you focus into this expression and this expression, they are merely the same expression with just a single difference, that one is having plus in the middle and the other is having minus in the middle. So we'll see what exactly it means. And the options are -1, 0, 1, 2. So if you observe closely, it is in the form of a plus b to the power 5 plus a minus b to the power 5, where x can be substituted with a and under root x cube minus 1 can be substituted with b. So we have to do the binomial expansion to expand and expand each separately. So this question again is also instructive. You need to expand both separately and add them to get the final expression. So add both the expansion to get the final expression, and then add all the coefficient of odd degree terms, which means you have to select the coefficients from the final expression and add them and choose the correct options. So whatever you get the answer, you have to cross verify with the options. Moving to the second part of our analysis, that is detailed solution. As we have already discussed in the first part, this expression would be replaced with a plus b to the power 5, which means x would be replaced by a and under root x cube minus 1 would be replaced by b. And the other expression, x minus under root x cube minus 1 to the power 5 would be replaced with a minus b to the power 5. And same substitution, x would be replaced with a and under root x cube minus 1 would be replaced with b. Now before we go further, we must know what is the expansion of a plus b to the power 5. We'll be using the general binomial expansion, and it will result in 5c naught a to the power 5, 5c1 a to the power 4 b1, 5c2 a cube b square, 5c3 a square b cube, 5c4 a1 b to the power 4, 5c5 b to the power 5. And for a minus b to the power 5, there won't be any change in the result, except wherever we see the odd power of b, that would be replaced with minus b, because a plus b and a minus b, the only difference is plus b has been replaced with minus b. Now looking closely to the expansion, we see these two terms are of opposite sign, and these two terms are of opposite sign, and these two terms are of opposite sign. So if I add these two expressions, they will neutralize these two terms would be neutralized, these two terms would be neutralized. So only this term would add up, this term would add up, this term would add up, because all the three circled ones are with the same sign. So if I add up, they all add up together. So a plus b to the power 5 plus a minus b to the power 5 can be written as twice of 5c naught a to the power 5 plus 5c2 a cube b square plus 5c4 a to the power 1 b to the power 4. Now opening it up, 5c naught would be replaced with 1, so it will be 2a to the power 5. The second term would be, opening it up, 2 into 10 a cube b square, because 5c2 is equal to 10. And then 5c4 would be replaced by 5, so 2 into 5 a into b to the power 4. So finally we'll be getting 2a to the power 5, 20a cube b square plus 10a b to the power 4. Now moving forward, we got the expression as 2a to the power 5 plus 20a cube b square plus 10a b to the power 4, but the question was in x, so we have to substitute back. So a would be replaced with x and b would be replaced with under root x cube minus 1. So by replacing it back, 2a to the power 5 would become 2x to the power 5, 20a cube would become 20x cube, and b square would become x cube minus 1, and 10a would become 10x, and b to the power 4 will become x cube minus 1 ka square. Now rearranging it and expanding it, we'll be getting 2x to the power 5, 20x to the power 6 minus 20x cube plus 10x to the power 7 plus 10x minus 20x to the power 4. So rearranging it in a descending order, we'll be getting 10x to the power 7, 20x to the power 6, 2x to the power 5, minus 20x to the power 4, minus 20x cube plus 10x. The green terms are all the all the terms with odd degree. So this is what the question is all about. Thus adding the coefficient of all odd degree terms, 10 plus 2 minus 20 plus 10 equals 2. So 2 is option 4, hence option 4 is the correct choice. Now the third part of our analysis, that is concept. In this we'll be discussing some basic concepts of binomial theorem. Before we begin, we'll analyze what is 1 plus x to the power 10. What exactly it means. So if you ask simply, it means 1 plus x into 1 plus x into 1 plus x up to 10 times. Well, then what would be the coefficient of x to the power 10? If we look without any complexity, it is 1 plus x into 1 plus x into 1 plus x up to 10 times. What does it mean? It means we have to select 1x from this, 1x from this, 1x from this. Likewise, we have to select from each of the 10 guys 1x. So we have to select 10x from 10 terms 1 plus x, which means each x from each 1 plus x. So selecting 10x from 10 1 plus x, that would be 10c10 using the selection. Well, then what would be the coefficient of x to the power 4? Again, we will look at the same way, that 1 plus x multiplied with 1 plus x into 1 plus x up to 10 times. But now the scenario says out of every term 1 plus x term, we don't have to ask from each term the x, but only 4 of the 10 has to be taken 1x, and from rest we just have to take 1. So it means we have to select 4x from 10 terms, that is 1 plus x, which means x from 4 of the 10 and constant 1 from rest of the 6. So selecting 4x from 10 1 plus x, that would be 10c4. So each 4 would be giving me x, and then the rest 6 would be giving me 1. And similarly, coefficient of x to the power 9 in 1 plus x to the power 25 is going to be 25, choose 9, because out of 25 1 plus x, we have to ask 9 of them just give us x, and rest will be taking 1. So 25c9 into 1 to the power 16. And for the coefficient of x to the power 11 into 1 minus x to the power 24, again out of 24 1 minus x, we just have to ask 11 of them to give us x, the rest 13 we will be taking minus 1. So minus 1 would be multiplied 13 times, so we can say minus 1 to the power 13. So concluding, 1 plus x to the power n would be expanded as nc0 x to the power n plus nc1 x to the power n minus 1, nc2 x to the power n minus 2, then it goes on till ncn. If you focus, it starts with nc0, then nc1, then nc2, and ends till ncn. It's the first term will have x to the power n, then the n minus 1, x to the power n minus 1, then x to the power n minus 2 till x to the power 0. And as you can see, there are 2 terms in the expression, and the power is n, so total number of terms will always be n plus 1. And for predicting 1 minus x to the power n, you just have to replace x with minus x, no change in the expression. In the end, you can write minus 1 to the power n ncn. And hence a plus b to the power n, again it will begin with nc0, then nc1, then nc2, ncn minus 1, ncn. So total n plus 1 terms. The a will start with a to the power n, then it will subsequently decrease with a to the power n minus 1, then a to the power n minus 2 till it becomes a to the power 0, that is 1. And b will begin with b to the power 0, and then it goes to b to the power 1, then b to the power 2, and it will become b to the power n.